Hello everyone. In this class we will see class 11 chapter 1 sets. We will cover all the topics and its important questions we will solve one by one. So look at the first question. Which of the following is a finite set? So look at the first option, x such that x belongs to z means integer and x square is even. Okay. So this is infinite set. Why it is infinite? Because if you take any even number integer, then the square is also even. Okay, so there are infinite integers are there which square is even. Then second, C option, x belongs to r means real number, 0 less than x less than 1, that means it is open interval 0 to 1. So interval is always infinite set. Okay, so this is also wrong. Then look at the option B, x such that x belongs to n means natural number such that comma x greater than 5. So more than 5 there are infinite numbers, so this is also infinite set. Okay, but if you look at the option number D, x belongs to integer and it satisfies this condition, x square minus 5x plus 6. So if we solve this quadratic equation, we know that quadratic equation has only two roots, two zeros. So the roots of this quadratic equation is x minus 2 into x minus 3. This is a factor. So the roots are x is equal to 2 and 3. Okay, so in this set D, only two elements are there, 2 and 3. So this is nothing but a finite set. So our correct answer for this question is D. Look at the next question. If A is subset of B, then which of the following is true? So if you don't know the result, then you can take the example. Otherwise, if A is subset of B, then for A union B, for union, the correct answer is the bigger set, that is B, and for intersection, the correct answer is smaller set, that is A. Okay, in case of only this condition is given, then only. Otherwise, if you take the example, let's say A is equal to 1 comma 2 comma 3 and B is equal to 1 comma 2 comma 3 comma let's say 4. So you can see that here A is a subset of B, so this condition is satisfied. Okay, so the first option, intersection is empty. No, if you find out intersection, A intersection B, so intersection means common elements. So which elements are common here? 1 2 3, 1 2 3. So intersection is 1 comma 2 comma 3, and if you look at properly, this intersection answer is nothing but exactly same as A. So A intersection B is equal to A, so correct answer is B here. Okay, and if it is asking about the union, then in case of union we will get answer B. Okay, remember this results. Look at the next question. Taking a set of natural number is a universal set. Okay, so universal set is our natural number 1 2 3 4 and so on. A set is given x such that x minus 8 is equal to 3, means it satisfies that condition. So if we solve this condition, we will get x is equal to 3 plus 8, which is nothing but x is equal to 11. So in this set A, we have only one element, that is 11. Now what is the question? Then A complement. So what is the A complement? A complement means universal set difference A. Means remove the element from the set A and whatever is remaining, that is our A complement. So universal set is what? Natural number. Difference A set means only one is element 11. So from the natural number 1, 2, 3, 4, 5, 6, so on, we have to remove only one element 11. Okay. So A complement is natural number? No. Singleton 5? No. And difference 5? No. Only all the natural number except 11. So correct answer is D. Look at the next question. Some sets are given. No. We have to justify they are sets or not. So the first one, the collection of all the states of India. So is this a set? Yes, this is a set. Why? Because this collection is well defined for everyone. It is not changing. Okay, it is not different for everyone. Second, the collection of first five prime minister of India. So this is a well defined collection. No, first five prime minister of India. That is for everyone. It is same. It won't change. So yes, this is also a set. Third question, the collection of best cricketers of India. Okay, so this is choice, depends on every person. So this is not a set. Why not set? Because for everyone it is best cricket players is different. So this set is not well defined. So that's why it is not a set. Then 4, collection of all the prime numbers. So yes, this is well defined. Yes, it is a set because the prime numbers are for everyone it is same, well defined. It is not different for everyone. Fifth one, the collection of hard chapters in maths. So this is not a set, not set. Okay, why? Because for every person, some the person who like maths, for them the chapters are easy some, and for the person who don't like maths, for them the chapters are difficult. So it is matter of choice. So this is not well defined, so this is not a set. Look at the next question. The next topic is belongs to. So remember, between element between element and set. So between element and set, belongs to or does not belongs to symbol will come, and between two sets, subset or does not subset, this element sign will come. Okay. So look at one set is given 0, 2, 4, 6, 8, 10. So we have to insert the symbol belongs to or does not belongs to. So the first one, 4. Is 4 is there inside this set? Yes. So 4 belongs to this set. Then minus 4 is not there, so does not belongs to A. 0 is there, so 0 belongs to A. Then 12 is not there, so does not belongs to A. 8 element, okay, these are the elements. So 8 is there, so 8 belongs to set A. Negative 2 is not there, so does not belongs to set A. Okay. So remember this condition, between element and set, this sign belongs to or does not belongs to, and between two sets, subset or does not subset will come. The next important thing is convert the roster form. So in all these questions, set builder forms are given. We have to convert into roster form. Roster form means what? We have to write down all the elements. So first question, x such that x is a prime natural number between 10 and 20. So what is the roster form of this question? Between 10 to 20, which prime numbers are there? 11, 13, then 17, after that 19. So this is the roster form of the set A. Second, x such that x belongs to integer and x square is less than 20. So the roster form of the set B is all the element in integer and that satisfy this condition. So condition is what? That square is less than 20. Okay. So if we take 1, so 1 square is what? 1, which is less than 20. Yes, so 1 will come. Similarly, 0 square is 0, less than 20, so that will come. Okay. Negative 1, so minus 1 square is also same, 1, which is less than 20. Okay. Then 2 and minus 2, 2 and minus 2, square of 2 and minus 2, which is 4, that is also less than 20, so that will come. Square of 3 and square of minus 3, that is 9, less than 20, so that will come. Then square of 4 and square of minus 4, which is equal to 16, less than 20, so that will come. Then 5 and minus 5, that square is 25, which is more than 20, so that won't come. So which numbers will come? Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. If we take the square of these numbers, the answer is always less than 20, so these elements will come in the set B. Then C set. So C set is given x belongs to natural number, comma, x is equal to 2 times n. So multiple of 2. Okay, 2 times n means multiple of 2. And x belongs to where? Natural number. So if you put the first natural number, that is 1, so 2 into 1, 2. If you put n is equal to 2, then 2 2s are 4, then 6, 8, and so on. Okay, so this is a multiple of 2. This is an infinite set. Then if we convert D set into roster form, so D set is given x is an integer which satisfy this condition, x square minus 9 is equal to 0. So if we solve this, x square minus 9 is equal to 0, that means x square is equal to 9. So x is equal to plus or minus 3. Root of 9 means plus or minus 3. So we will get only two elements, minus 9 and plus 9. So this is the roster form of set D. Then look at the set E. X is the positive factors of 80. So which number divides 80? That all the numbers we have to write down. So 1, 2, 3, 6, then 9. Okay, so these are the, okay, 18 is also the 18. So these are the positive factors of 18. So this is a roster form of set E. Look at the next question. Now the converse part. Roster forms are given. We have to write down set builder form. So look at the first question. A is given 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 and so on. So look at the pattern. In the starting we'll write x such that x is equal to, okay, this much it is same. Now what is the pattern? So you can see that numerator is 1 fixed. So we'll write the fixed number first. So numerator 1 is fixed. It is not changing. Upon. Now look at the denominator. How denominator is changing? 2, 3, 4, 5. So here in the first digit we can write down 1 as 1 upon 1. So here 1 is there. Okay. So these are nothing but the natural numbers. So we can write down here n. Okay. So whatever number is changing in that you can write down n. So our formula is set up. X is equal to 1 by n. Now comma. N is starting from where to where? So these are the all natural numbers. Okay, so you can write down n is nothing but 1, 2, 3, 4 and dot dot dot, or you can write down like this, n belongs to natural number instead of that. So one of them you can write down. So this is a set builder form of the first set A. Now look at the set B. So in the set B it is nothing but just integer numbers between -2 to 4. So set B we can write down as x such that x belongs to integer z, and from where to where, let's write -3 less than x less than 5, between -3 and 5, and -3 and 5 is not included here. Okay, then look at the set C. So in set C what you can see here, in the numerator 1, 2, 3, 4, 5, 6, 7. Okay, that is okay. So x is such that x is equal to, numerator changing, let's say numerator is n. Okay, 1, 2, 3, 4, 5, 6 upon. Now look at the denominator. So denominator is what? 2, 5, 10, 17, 26. Okay, like that. So what is the pattern here? So if you look at carefully, in the numerator 1 is there. So 1 square is 1, and if you plus 1 then you will get 2. Okay, 1 upon 1 square plus 1, that is 2. Second number in the numerator 2, then in the denominator 2 square, which is 4. So 4 plus 1, 5. Then in the numerator 3, then 3 square, which is 9. So 9 plus 1, it is 10. Okay, so you can see the pattern. Whatever numerator is there, square of the numerator plus 1. 4 square is 16, 16 plus 1 is 17. Similarly here 5 square is 25, 25 plus 1, 26. So what we can write down, if numerator is n, then denominator is n square, and then plus 1 is fixed here. You can see that after plus 1 is fixed. So n square plus 1. Okay, so this is the pattern. Now we'll write n is taking which values. So n is taking, here infinite set is not there, only finite. So n is taking only 7 values, 1 to 7. So we can write down n is equal to 1, 2, 3, 4, 5, 6 and 7. Okay, so this is our set C. Now look at the set D. So what is set D? It is just a natural number between 10 to 15. So you'll write x such that x belongs to natural number from where to where? Let's say 11 less than x, sorry, not 11, 9 less than x less than 16. Okay, or you can write down like this also, 10 less than equal to x less than equal to 15. Okay, one of the way. Then last set E. So what you can say, see in the set E, 2, 5, 1, 2, 5, 10. So these are the numbers nothing but factors of 10. So we can write down as x such that x is a factors of 10, factors of number 10. Okay, this is a, or you can write down the divisor of 10, x such that x is a, you can write natural number which divides 10, or the factors of 10. Okay. Look at the next question. Again, set builder forms are given. We have to list the element roster form. So the first one, x such that x square less than 10 and x belongs to integer. So which numbers are there in the integer? If you take the square, the answer is less than 10. So just now we have done, in that 20 was there, here 10 is there. Okay, so answer will be what? Minus 3, minus 2, minus 1, 0, 1, 2 and 3. Okay, because the maximum number is 3. 3 square is 9. So 9 is less than 10. If you take 4, then 4 square is 16, which is not less than 10. So only these numbers will come. Set B. So what is the roster form? X is the letter of the word equation. So we have to write down one by one letter. So E, then Q, then U, A, T, I, O, and N. Okay. All the letters are distinct, so we have to write down all. Then look at the set C, x such that x is a solution of x square plus 5x plus 6 is equal to 0. So if we solve this quadratic equation, we will get two roots. Okay. So the roots are nothing but x plus 2 and x plus 3. If you equate with 0, we will get minus 2 and minus 3. This is the roots of this quadratic equation. So these two answers will come here in the set C. Now look at the set D. So in the set D, what is given? X is equal to n upon n plus 1, where n is less than equal to 9 and n belongs to natural number. So natural number is starting from where? 1 until which number? 9 number. Okay, so if we put 1, so 1 upon here 1 plus 1, which is 2. So this is the first element. If you put n is equal to 2, then 2 upon 2 plus 1, which is 3, then 3 upon 4, 4 upon 5, and so on. It will continue in this manner: 5 by 6, 6 by 7, 7 by 8, then 8 by 9. Okay, then 9 you cannot take, because if you take 9, then it becomes 9 upon 10. Yeah, okay, 9 upon 10 is the last. Then 10 you cannot take, because the number is saying n less than equal to 9, not more than that. Okay, so this is a set D roster form. Now look at the set E. So what is the given? X is equal to 1 upon 2n minus 1. N is again belongs to natural number. And which natural numbers we have to take? 1 to 5. So 1, 2, 3, 4, 5 only. So first element 1 upon. If you put n is equal to 1 here, so 2 ones are 2. 2 minus 1, which is 1, comma. 1 upon. If you put n is equal to 2, so 2 2s are 4. 4 minus 1, 3. Then if you put n is equal to 3, then 3 2s are 6. And 6 minus 1, which is 5. Okay, and then you will get 1 by 7, and again in the last 1 by 9. So this is a roster form of the set E. Look at the next question. Here we have to match this list, first list with second. So in the first column, roster forms are given. In the second column, set builder forms are given. So you can see that first is matching with D directly, because here the letters are given, that is connected with the word school. Then here first option is a positive factors of 12. So in first column, where is the positive factors of 12? In the third option. So this is matching with the first one. And then here x is equal to n plus 1, where n belongs to natural number and n is less than 6. N is less than 6 means which number? 1, 2, 3, 4 and 5. So if you put n is equal to 1 here, so 1 plus 1, 2. Then if you put 2, then 2 plus 1, 3. So where is this numbers? Here. Okay, so the last option is matching with B. Now only one is remaining, that is 0. That will match with C. You can see that x plus 5 is equal to 5. So if you solve, x is equal to 5 minus 5, which is 0. So that is here. Look at the next one. Which of the following sets are empty set? We have to check whether that is empty or not. So the first one, x such that x belongs to R, x square plus 2 is equal to 0. Okay, so if you solve, x square is equal to negative 2, so you'll get x is equal to square root of minus 2, which is not there in the real number. This type of number is called complex number, which is not there in the real number. That means the first set is empty. Means there is no number which satisfies this equation. Can you imagine a number if you take the square and if you add up plus 2, you will get 0? Never, no, in the real number. So that's why it is empty. Second, x such that x belongs to natural number where x is between 5 and 6. So is there any number between 5 and 6 in the natural number? Okay. Natural number means 1, 2, 3, 4, 5. So after 5 directly 6 will come. There is no number between 5 and 6 in the natural number. So that means this is also empty set. Next, x such that x belongs to natural number and x square is equal to 9. Okay. So if we solve this, x square is equal to 9, what we will get? X is equal to plus or minus root 9, which is plus or minus 3. So minus 3 is not there in the natural number, but plus 3 is there. So 3 belongs to natural number. So in this set, one element is there, 3. So this is not equal to empty. This is not an empty set, third one. First is empty, second is empty, third is not empty. The next, x square minus 2 is equal to 0. Okay. So if we solve this, x square is equal to plus 2, then x is equal to plus or minus root 2. And root 2 is which number? It is irrational number. Root 2 is a irrational number. But here it is, we want rational number. So this is also empty set because we are getting irrational number if we solve this condition. Then x such that x is neither prime nor composite. Okay. So neither prime nor composite means if you take any number, either it will be prime or it will be composite, except 1. Okay, 1 is neither prime nor composite. So here also one number is there. So this set is also not empty. Okay, because 1 is not prime neither composite. So one element is there in this set. That's why this is not empty. Next question, we have to check whether the sets are finite or not, infinite. So the set of concentric circle in a plane. So concentric circle means this is one circle with a center, let's say this. So concentric circle means center is same. So how many circles you can draw in a plane? There are infinitely many circles we can draw concentric in a plane. Okay, so this is infinite set. First one is infinite. Second, x such that x belongs to R. R means real number and 0 to 1 means it is open interval 0 to 1. So interval is always infinite. Second is also infinite. Third one, the set of odd natural numbers. So odd natural number means 1, 3, 5, 7. So it is continue in this manner. So this set is also infinite. Then next, x such that x belongs to n means natural number x less than 200. So natural number but less than 200. So less than 200 means 1 to up to 199. So this is a finite set. This is finite set. And the last one, x belongs to integer and x less than 5. So this is infinite set. Why? This is infinite because less than 5 means 4, 3, 2, 1, 0. But here minus negative numbers are also there because this is integer, set of integer. So minus 1, minus 2 and so on. So there are infinite numbers less than 5. So this last set is infinite. Look at the next question. From this given set, which sets are equal, that we have to tell. So look at the first one, x belongs to natural number less than 3. So which numbers will come? Less than 3 means 1 and 2. Okay, that means the set A and set B are equal. A is equal to B. Then set C and set F, that also you can see that here also element 3 and 1, here also 1 and 3. So C is equal to D. Look at the set D. Okay, E set is 1, 2, 1. So that is also equal to AB. So A, B and E sets are equal. C and D are equal. And set D, x such that x belongs to natural number, x is an odd number and less than 5. So natural, odd and less than 5. So natural number of less than 5 is what? 1, 2, 3 and 4. Now we want odd numbers only. So 2 and 4 will remove. So which number will remain? 1 and 3. So set D is nothing but 1 and 3, which is same as C and F set. Yeah, C and Yeah, C, D, and F. These three sets are equal. C, D, and F. Okay. Look at the next question. Now we have to fill the symbol subset or does not subset. Okay. So the first one, this is nothing but empty set. Okay, like this is written, that means empty set. So empty set is always a subset of any set. Then second, so if you look at the second question, here only A is written. So A means this is an element. So element never a subset of any set. Between element and set belongs to symbol will come. Element and set belongs to symbol will come. Okay. So this is not a subset. This is wrong. Then third, now it is written in a set form. So set A is a subset of ABC. That is correct now, because between two set subset sign will come. So this is a set and this is a part of this ABC. So here subset will come. Then next one, 2, 4, 6. It is a part of this. Yes. So this is a subset. Then XYZ, and here also XYZ. So it is exactly same. So yes, it is a subset. Okay. Look at the next question. We have to check which of the statement are true or false. So the first one, empty z is a subset of x comma y comma z. So this is true. The next, a letter in the word school, subset of letter in the English alphabet. So this is a part of, okay, this is also the part of all the alphabet. So this is also a true statement. Then the set pi is subset of r, real number. So pi is irrational number. So irrational number is a part of a real number. So this is also a true statement. Next, pi is a subset of natural number. So this is not true. Pi is irrational number, that is not a part of natural number. So this is false. Next, X is the collection of all the birds, and here the collection of the parrots. Okay, so all the birds is not a part of the collection of parrot. So this is false statement. Look at the next question. Which of the following statement are correct? So look at this set properly. A is given. A, this is element. B, this is element. And after that, like this is given C comma D. So this is a single element. Okay, C comma D is a single element, comma E. So in the set, how many elements are there? 1, 2, and this is one single element, and this one 4. Okay. This first question, A comma B comma C is a subset of A. So this is false. Why? Because A is there, B is there, but C element is not present here singly. C with D is single element. Okay. So this is false. Second, empty set belongs to A. So belongs to sign won't come. Empty set is a subset of A. Okay. Because of this belongs to sign, this is false. Then third, now single element is given C comma D. So C comma D, this is there in the set A. Yes, it is a subset of A. So this is true, because now it is subset sign is given. Fourth, A belongs to A. So A is an element and it is belongs to set A. Yes, so this is true. Then A comma B comma E, this is a set. So this set is a subset of A. So A, B and E. Yes, it is a part of A. So this is a subset. This is also true. Look at the next one. Write the following as an interval. Okay. So interval how to write? If it is less than equal to, then we have to write down close. If it is strictly less than, then we have to write down open. So look at the first one. Write down the number first. So 5 comma 12. So 5 is here less than equal to, so close. Here also less than equal to, so here also close. So this is close interval 5 to 12. Second, 0 is open here, so 0 open, and 8 is close. So 8 is close. So 0 to 8, but 8 is there here. Okay, close interval means that number is included. Minus 2 is open, 5 is also open. So interval is open minus 2 comma 5. Next, 4 is close, 16 is open. So 4 is close and 16 is open interval. Okay, so these are the intervals of this question. Now the converse part, we have to write down the set builder form. So for the first one, x such that x belongs to real number. Okay, intervals when you're writing, then always you have to write down the real number. So minus 7 and 1, both are open. So how to write? X is between minus 7 to 1 open. So this is the set builder form of the first one. Similarly, you can write down for the second one like this: 0 less than equal to x less than equal to 10. Okay, remaining thing is same. And for the third one, 1 is open, so 1 less than x less than equal to 18, because 18 is closed. This part is same. And for the fourth question, 0 is closed, so 0 less than equal to x and less than 8, because 8 is open. Okay, so these are the set builder form of interval. Now the next topic, that is union. We have to find out the union of this pair of the sets. So A is given 2, 4, 6, 8, B is given 1, 3, 5. So what is A union B? Union means we have to combine both the set. So union will be 2, 4, 6, 8, 1, 3, 5. Or you can write down 1, 2, 3, 4, 5, 6, 8. Okay. So this is the answer of the first one. Look at the second one. A set is given x such that x is equal to 2n plus 1, n belongs to integer, and B set is x is equal to 2n where n belongs to integer. Okay, so A set is given what? 2n plus 1. So 2n plus 1 means this is nothing but an odd number. Okay, this is how to write down the odd number. So in this set we have 1, okay, 1, 3, 5. Not only positive, negative number is also there, plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 7, and so on. And in the set B, it is given that x is equal to 2n, where n belongs to natural integer. Okay, so integer means all the positive and negative number. No, so if you put positive number, you will get positive. For negative, you will get negative. So 2n means all the even numbers. So in this, we'll get 0. Okay, 0 will be there in both the set. Okay, 0 is neither even nor odd. So here plus or minus 2, plus or minus 4, and so on. So if we take the union A union B, we will get all the integer, odd and even. That means your answer is nothing but exactly the full integer set Z. Okay? Because if you combine odd and even integer, you will get the whole set integer. Look at the third one: 1, 2, 3, 4, 5, and 2, 3, 5, 7. So what is union? A union B is equal to 1, 2, 3, 4, 5, and 7. So this is a union. Look at the next question. A set is given, B set is given. We have to find out A union B. So what is A union B in this case? Just combine the A set and B set. So 1, 2, 3, 4, 5, 6, 7, and 8. Next one, B union C. So what is B union C? Combine the B set and C set. So 4, 5, 6, 7, 8, 9, 10, and 11. So this is the answer of B union C. Look at the next question. Now we have to find out A union B union C. So that means combine all the three set A, B, and C. So which elements we have to write down? A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. So this is the answer of A union B union C. The next question is A intersection C. So look at the set A and look at the set C. Now the question is intersection. So intersection means common element. So which elements are common in A and C set? So here it is 1, 2, 3, 4, 5, and here it is 7, 8, 9, 10, 11. So no element is common. So the answer is empty set. Okay, so empty set you can write down like this, or you can write down like this. Look at the next one. We have to find out A intersection B union C. So to find out this question, we have to solve first B union C, whatever is there inside the bracket. So union means combine B and C set. So B is 4, 5, 6, 7, 8, and C is 7 and 8 ordinarily we have written. So 9, 10, 11. Now we have to find out A intersection B union C. So to find out this, just look at the set A and look at the set B union C, because we have to find out the intersection between which set? A and B union C. So which elements are common here in A and B union C? 4 and 5. Only two elements. So the correct answer is 4, 5. Look at the next question. A intersection B union D. So again the same thing. We will find out first B union D. So B is 4, 5, 6, 7, 8. D is 10, 11, 12, 13, 14. So 4, 5, 6, 7, 8, 10, 11, 12, 13 and 14. Then we have to find out A intersection B union D. Okay. So intersection between what? A and B union D. So look at the set A, which is 4, 1, 2, 3, 4, 5, and look at the set B union D. Which elements are common? That only we have to write down. So only 4 and 5 are common. So the intersection is answer 4, 5. Look at the next question. Now the question is on disjoint. So when we say two sets are disjoint, when the intersection between two sets are empty, then it is called disjoint. Okay, is there is no overlap. If overlap is there, then intersection is not empty. So this is called not disjoint. But if the two sets are completely like this, different, there is no overlap, so that is called disjoint, empty. So look at the first one. X belongs to natural number and 1 less than x less than 5. So which element will come here inside? Natural number between 1 and 5. That means 2, 3 and 4. Second set, x belongs to integer between -5 and 1. So which integer will come between -5 and 1? -4, -3, -2, -1, 0. Okay. So is there any common part here? There is no common part. If you take the intersection, you will get empty set. There is no common element in this two set. So this first question, these two sets are disjoint. Look at the next question. This first set is X is a letter in the word July. So if you write down in the set J, U, L and Y. This is, let's say, set A, and the second set is the letter in the word March. So if you write, let's say, set B, so letters are M, A, R, C, H. So is there any letter common here? There is no letter common. That means A intersection B is equal to empty. So these two sets are also disjoint. Look at the next third one. 2, 4, 6, 8, 10 and here 2, 3, 5, 7, 11. So let's say this is set A and this is set B. So what is A intersection B? Is there any common element? Yes, here 2 is common in both the set. Okay, so we can write down intersection is 2, which is not equal to empty set. So these two sets are not disjoint. Not disjoint. Okay. Look at the next question. A is given, B is given, C is given. What we have to find out first? A minus B. Okay, A difference B. That means look at the set of element of A and look at the set of element of B. We have to write down only the element of A which is not there in B. So A difference B will be, here 1 is there, here also 1 is there, so that we don't have to write down. Cancel out. Then 2 is here 2 is there, no, so write down. Then here 3 is there, in this set also is there, so cancel out. Here 4 is there, here 4 is there, in the set B, no, then write down. 5, here it is there in the set B, so we don't have to write down. So A minus B is 2, 4. Similarly A minus C. So A minus C means again we have to look at the set A. So in the set A, we have to write down all the element which is not there in C. So look at C set 1, 2, 3. So remove 1, 2, 3 from here. 1, 2, 3. What is remaining? 4 and 5. So the answer is 4, 5. Okay. Next, B minus C. B minus C. So look at the set B first. 1, 3, 5, 6. In the set C, which element is there? 1, 2, 3. So remove 1, 2 is not there and remove 3. So which is remaining? 5 and 6. So B minus C is 5 comma 6. Then look at the fourth one, A minus B minus C. So to solve this, we'll find out first of all B minus C. So B minus C we already have 5 comma 6. Okay. So now we will find out A minus B minus C. So A is what? 1, 2, 3, 4 and 5. Minus B minus C is what? 5 and 6. So remove the element 5 and 6 is already not there. So which element is remaining? 1, 2, 3 and 4. Okay. 6 we don't have to write down. Only this set elements we have to write down, which is not there in this set. Okay. So this is the answer. Look at the fifth question. A minus B intersection C. So to solve this question first, we have to find out B intersection C. That means which elements are common in B and C? So in B and C, 1 is element common, 3 is common. So B intersection C is 1, 3. Then we have to find out A minus B intersection C. Okay, so A set is what? 1, 2, 3, 4 and 5. Minus B intersection C is what? 1, 3. So remove this element 1 and 3. So 1 and 3 if we remove, what will remain? 2, 4 and 5. So the correct answer is 2, 4, 5. Okay. Look at the next question. Universal set is given, A set is given, B is given, C set is given. We have to find out A complement. Okay. So A complement means what? Universal set minus A. From the universal set, remove the element of A. Okay. So which elements are there in the set A? 4, 8, 16, 12. So remove 4, 8, 16 and 12. So which element will remain? 2, 6, 10, 14, 18 and 20. Okay. So this is the answer of A complement. Similarly B complement. So B complement means what? Universal set minus set B. So remove the element of B from the universal set. Okay. So B set is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So remove the 1, 2, 3, 4, 5 from the universal set. So 1 is not there, 2, 4 and 5. So remaining 6, 8, 10, 12, 14, all the elements we have to write down. 6, 8, 10, 12, 14, 16, 18 and 20. Okay. Similarly, you can find out the third question, A intersection B the complement. So to find out the third one, you have to find out A intersection B first. So what is A and B intersection? Intersection means common element. So which elements are common in A and B? Only 4. Okay. So A intersection B is only 4 singleton. Now what we have to find out? A intersection B complement. A intersection B the whole complement. So what is the formula of complement? Universal set minus the complement that we have to find out. So U minus A intersection B. Okay. So from the universal set, which set we have to minus? A intersection B. So what is A intersection B? Only singleton set 4. So remove the 4 from universal set. So only 4 element we have removed. So remaining 2, 6, 8, 10, 12, 14, 16, 18, 20. All these element will come. Okay. Similarly, you can try the question number 4 and 5. Okay. Then question number 28, in that also you have to find out the complement. So try this question for your homework. Only complements you have to find out. So if you like this video, then share with your friend and don't forget to subscribe. Thank you.